So we'll discuss about the test for autocorrelation. The test for autocorrelation is concerned with the dependency between the number of sequence. For example, you have given this sequence of numbers like this. Suppose this is the sequence of numbers is given to you. And from this sequence of numbers, the number appear is a random if they probably pass all the tests present to this point, and we have to check whether the fifth place, 10th place, 15th place, that means every five numbers being with the fifth indicates the very large number that you can see that 85. This is the fifth place, then it is 93, then it is 91, then it will be 88, then 0.95, 87. They are the very large number in that position. Now, if the 30 numbers we have generated and the fifth place is the randomly, it will be large, that we have noticed in this 30 numbers. Now, if the 30 number is rather the small sample of size on which we reject the random generation. So from this, looking at this situation, we can reject that. But it may possible when we generate 100 of number or 10,000 of numbers, and in that, if the same scenario is occur, so it is very difficult, or the relation could not be have of all high numbers. So that means in that case, it is possible to have all low numbers in location being examined. So the location could not be, you can find out, or the numbers should be alternating from very high to very low. So such type of situation that we need to looking at the situation. The test to be described here shortly required the computational for autocorrelation between every m numbers. And what is m is actually gives you a gap or lay between this. For example, here the lay is 5. So thus the autocorrelation coefficient that we denoted by rho m, and between the following numbers we could interested into the ri plus m, ri plus 2m, up to so on, ri plus capital M plus 1 into small m. This small m, capital M is a very large integer such that I plus capital M plus 1 into small m is less than or equal to capital N, where capital N is the total number of values in the sequence. So let us repeat what I have talked. We are in this autocorrelation test, we are examining this random numbers, which I mean the gap between these two random numbers will be m. So we are examining this ri plus m, and so on. And this capital M is a very large integer that we can take, but with the condition that this quantity, that means this one, is less than or equal to number of samples. For example, here is a 30, so it should not be beyond 30. So that's why this restriction is there. Now we set the what is our hypothesis for this. So H0 is the null hypothesis that we are taking, that this two-tailed test is appropriate when this autocorrelation coefficient is 0 and H1 is this autocorrelation coefficient will be non-zero. A non-zero autocorrelation implies there is a lack of independency is there. If the autocorrelation is 0, then it will implies that there is a independency is there. Okay. So for large value of m, the distribution of estimator, that is rho im, denoted by rho im cap. For large value of m, the distribution of the estimator, this is the estimator, will be denoted by this, and it is approximately a normal to this. So it will have, this is the distribution it will give, and this portion, this is called, this is actually alpha by 2. I have critical value. This is also alpha by 2. This is z alpha by 2, and this is, so this value will reject with this. So that is the, a test static can be formed, that is z0, which is rho I m cap upon rho I m. This is our static, and which distributed normally with the mean 0. So this is 0 mean, and the variance is 1 under the assumptions of independence of the large value of capital M. What is the formula for calculating this autocorrelation coefficient that was established by Smith and Taylor, and how it is established, we are not going into the detail of that, in 1970, and the formula is Im cap is 1 upon 1 plus m summation k running from 0 to capital N Ri plus km into Ri plus km plus 1m minus 0.25. So all this value will be of minus 0.25, and the variance, that is sigma of this one, is square root of 113 plus capital M upon 7, 12 into capital M plus 1. Then after computing this z, so we have now, we can able to compute this z0. This is rho of sigma. So we'll compute this z0, and after completing this z0, if do not reject the null hypothesis, that means your z0 is lies between this two value, that means minus z alpha by 2 to z alpha by 2. So that means this z0 is between this two. This is where alpha is the level of significance, and this value z alpha by 2 can be obtained from the normal distribution table. If it is between these two, then we can accept whether it is the independency is there, otherwise not. Okay. If this sigma, that means this sigma of Im is greater than 0, then we can say that. So that is a note we can write down here. If sigma Im is greater than 0, then it is a positive correlation is there. Positive autocorrelation is there. If this sigma im is negative, then it is a negative correlation is there. So this is the things which you need to note, and let's see the example and we'll understand via this quantity via an example. So the data is given as we have given in the previously what we have taken is the same data that we will have here, which we have taken earlier. So the question is test for whether the third, 8th, 13th, and so on numbers from below are of autocorrelation or not, or autocorrelated using alpha is equal to 0.05. So your alpha is this. So first of all, what is your small I? As per the previous things which we have started, that is Ri plus M up to goes on. We have to calculate what is capital M also here. The capital N value, it is according to this, it is a 30. So let us write all this information. Small I, due to this, it is 3. Small m, that is the leg, how much gap is between these two, that is 3, 8, the next term is 13, so the gap is 5, so the leg is 5. What is capital N is how much total number of entries or total number of data is given, it is 30. Now how to calculate the value of capital M? As per this, the capital M is I plus capital M plus 1 into small n is less than or equal to capital. So we will use that one and we'll calculate what is capital M. So we have I plus capital M plus 1, 5 less than or equal to capital M. 5 is a small m. The value of I is 3 plus capital M plus 1, small m is 5 less than or equal to 30. So this will gives you capital M plus 1, 5 less than or equal to 27. So capital M plus 1 is less than or equal to 27 by 5. So it is 5 point something. So capital M plus 1 is less than or equal to 5 point something minus 1, and M should be integer. So that's why this will be 4 because it is a 4 point something is there. So capital M we got from there, it is 4. So now this is the formula to calculate this row IM. I is 3, capital M is 5. So that will calculate row 3 comma 5. As per the formula, it is 1 upon 1 plus capital M. So it is 1 upon 1 plus capital M is 4 into summation I running from 1 to capital N, which is 30. But 30 should not be there because this sum is not 30, goes up to 30. So K is this. So what we have when K equal to 0 here, I is 3 and small m is, we have 5. So it is 3 plus, so it is R3. Let us write down that So I'm not writing this summation. That is R3 into the next number. As per the formula, it is m plus 1. So I is 3, k is 0. Okay. So 3 plus 5, which is 8. So next number is R8. Then next one is R8, 8 plus 5. That you can add 5 into this, which will be 13. Plus R13 into R13 plus 5. Because your n is 5. So 13 plus 5 is 18. Plus R18 into R18 plus 5 is 23. And R23 into 28. The next number should not be there. Next quantity should not be there. Because the next one is R28 into R32. We have only number is till 30. So we'll not write that one. Minus 0.25 as per the formula. Minus 0.25. Now, what is R3 that we can calculate? R3 is this 2, 3, 4, 5. This is the 0.28. Okay, we'll substitute that all value. That is 1 upon 5. 0.23 into 0.28. R8 is this 0.28. Then 13 is 0.33 plus 0.33 into 18. 18 is 0.27. 18, so plus 0.27 into 23. 23 is 0.05. Plus 0.05 into 28. Into 28 is 0.36. Minus 0.25. So use the calculator and I want the answer for this. What will be the answer? So I have already calculated this answer is minus 0.1945.
1945, minus 0.1945.
And we have to calculate this rho. The rho, that is, sorry, sigma of that quantity, sigma of rho 3 by 35. As per the formula, it is square root of 13 capital M plus 7 upon 12 into M plus 1. So that is, we can write square root of 13 into capital M plus 7 upon 12 into capital M plus 1. So capital M, value of capital M is 4. So it is 13 into 4 plus 7 upon 4 plus 1 is 5. So what will be this? In the denominator we have 60 and in numerator is just this. So you can have this value is 0.1280 by calculator. And then we can have the Z0 value, that is your static value is Z0. So the test static assumes the value Z0 is rho 35 upon sigma rho 35. This value numerator is minus 0.1945 and the denominator we have 0.1280. So this will give you minus 0.516. So this is the things we got, and into the critical value table that we need to check. So I will just draw that table in front of you.
So this value should be greater than 1, no? That denominator is smaller than numerator, so it should be greater than 1.
Check.
So 1.5195.
5195.
1.51.
51.
5195.
So this is the value you have. Okay. So let's see in the table what we have. So where to look at? What is your alpha is given to you?
0.05.
0.05. So alpha is 0.05. So here we have to look at it. Alpha is 0.05, but alpha by 2 we have to look, because as per this situation which I have explaining, alpha by 2, this portion we have to look. So alpha by 2 we have to look at the situation. So
Log level.
Z 0.025 we have to look into the table. So 0.025. Tell me what is that value if someone have the table. It is not here. And so it is the next.
So in statistical table, I have to find normal probability integral table, na?
Yes.
Okay.
Point 6985.
Point
6985.
1.96. It is what I have the value.
Yes, sir. 1.96.
Okay, therefore, what we can say? So the value is between minus to plus, in between. This value has to be in between. If it is between this, then we cannot reject. Okay, this Z0, and it is there. That means this, the value which are at the place, this thing, they are autocorrelated. That we can say from this. Fine. This, so this is the about the autocorrelation of this data. So I think so now I'll stop this recording, because now we'll doing some programming in R.